Hey class, welcome back to week 7, day 2 here of remote learning. All right, so hopefully yesterday's lesson made sense about solving quadratic equations using this idea of inverse operations and with square roots. Today we're going to do a couple more example problems that have a little bit more involved. All right, so if you didn't get a chance to watch yesterday's video and do the notes and homework, all right, you better do that first before you listen to this one, okay? So here we go. All right, so these are kind of the two takeaways from yesterday's notes. All right, and kind of the big ideas for solving quadratic equations using this inverse operations. All right, the first one is that we always want to isolate the quadratic term, right? That x squared term needs to be isolated, right? We have to get everything else away from that x squared term, and then you can take the square root of each side. All right, and also the other key idea here is that when you take the square root, right, you need to include that plus or minus sign, all right, because it is a quadratic equation, right? We're going to get two different solutions here, all right, and that's why we need to include that plus or minus sign. All right, and again, here are those perfect square numbers that we need, right? When we're simplifying radicals and we're taking square roots, right, we have to think of these numbers here, all right? Those are my perfect square numbers. All right, so here we go. We're going to just jump into a couple examples here, and then it'll be time for you guys to do some practice on your own. All right, so directions say, right, to solve the following equations using square roots, all right, or inverse operations. And there's a hint again, right? We talked about this yesterday, that a square root, right, a square root undoes a square, right? Those are inverse operations of each other. All right, so here we go. All right, so example 1, we have x minus 2 squared equals 100. All right, so here, right, there's my x inside this parentheses, and the whole thing is being squared. All right, so there it is kind of isolated, right? There's nothing outside of that x, right? That minus 2 is with that x, but it's being squared also. Okay, so and if that's the case, now I have to take the square root to break up that square. All right, and when I do the one side, I have to do to the other. All right, so the square root undoes the square. Right, those undo each other. So now I'm left with x minus 2 equals, well, the square root of 100. 100 is my perfect square number. All right, so it's going to be plus or minus 10. All right, and you're going to notice with today's problems that when we take the square root here, it's going to work out that they're going to be perfect square numbers. Okay, so now that we broke it up, square root of 100, or sorry, we simplified square root of 100 into plus or minus 10. All right, now we need to make two equations to finish solving this out. All right, we're going to need to make one equation with a plus 10 and one equation with a minus 10, and that's how we're going to get our two solutions here. All right, so this means that we're going to have x minus 2 is equal to that positive 10, or that x minus 2 is equal to a negative 10. All right, because when I square root, again, it makes a plus or minus 10. All right, so now I have to write out two separate equations, all right? But from here, right, these are our one-step equations now. Because here, I'm just going to add 2 here, add 2 here, and we get x is equal to 12. All right, and the same operations here, right? We add 2, but this time we have a negative 10 plus 2, and that's going to give me a negative 8. All right, so those are my two solutions, x equals 12 and x equals negative 8. All right, again, I need to show all this work, all these steps here to get those two answers. All right, let's try number 2. All right, number 2, we get x plus 6 squared is equal to 25. All right, so same thing, right? My x squared term, right, is isolated because there's nothing outside my parentheses, all right? This plus 6 is inside the parentheses, so I can't move it yet until I break this squared out of there, all right? And to do that, right, we take the square root of this side and we take the square root of that side, right? Because those will undo each other now. So now I broke that square away. All right, so now I'm just left with x plus 6 is equal to, well, the square root of 25, right? That's a perfect square number. All right, and that's just 5, but it's plus or minus 5. All right, because it's a quadratic equation, so I'm going to have a plus value and you're going to have a minus value. All right, so now that I took the square root of both sides, now I can set up my two equations. All right, so my first equation is going to be x plus 6 is equal to positive 5. And my second equation is going to be x plus 6 is equal to negative 5. All right, and now I'm going to solve both of these equations the same exact way, but I'll get two different solutions here, right? So I get minus 6 for this first one. So here I have 5 minus 6, well, that gives me a negative 1. And on this equation, right, I'm going to minus 6. All right, now I get a negative 5 minus 6. That gives me a negative 11 over here on this equation, or this solution. All right, so for example 2, those are going to be my two solutions, negative 1 and negative 11. All right, let's do a couple more here. All right, so in example 3, all right, this time, all right, what do we notice with example 3 here? Yes, right, there's this 3 out in front. All right, so this example 3, right, it's 3 times x minus 6 squared is equal to 27. All right, so now I need to isolate that x minus 6 squared value. All right, I'm going to isolate it by dividing this 3 out of there, right? I divide the 3 on my left side, I divide the 3 on my right side. So now we get x minus 6 squared, right? We haven't got rid of that square yet, is equal to 27 divided by 3 is 9. All right, now my x squared term is isolated. So now I'm ready to take the square root here on the left side. I take the square root on the right side. Right? Again, that square root gets rid of that square. So I'm left with x minus 6 is equal to, well, the square root of 9, again, that's a perfect square number, right, is equal to plus or minus 3. All right, and all of today's problems and on the homework, they're all going to work out with their perfect square numbers. All right, so now I'm ready to set up my two equations. X minus 6 is equal to positive 3, and x minus 6 is equal to negative 3. All right, and again, I'm going to solve both of these the same exact way, right, by adding 6 to both sides. All right, and my first solution is going to be 3 plus 6, which is 9. And then my second solution is going to be negative 3 plus 6, which just gives me a positive 3. All right, so those are my two solutions here for example number 3. All right, in example 4, it looks very similar to 3. All right, so why don't we go ahead and pause the video. I want you guys to work out example 4 all the way through and then tell me what your two solutions are. All right, let's see what we did here, right? Example 4 says 2 times x plus 3 squared is equal to 98. All right, just like in example 3, where you have to get rid of that number outside of our parentheses. All right, so we're going to divide both sides by 2. And now we're going to get x plus 3 squared is equal to 98 divided by 2 is 49. All right, now I'm ready to take the square root of my left side. Yeah, I'm ready to take the square root of my right side. All right, so again, the square root gets rid of my square. So now I'm left with x plus 3 on my left is equal to plus or minus. The square root of 49 is 7. So now I'm ready to make my two equations. All right, so I get x plus 3 is equal to positive 7, or I get x plus 3 is equal to negative 7. All right, and now I solve both of these the same exact way. All right, I'm going to subtract 3 to both sides on this first equation. So you get x is equal to 7 minus 3 is 4. All right, I'm going to minus 3 on the second equation. All right, except this time I get a negative 7 minus 3, and that gives me a negative 10. All right, just be sure you're using a regular calculator here, especially since we're dealing with negative and positive numbers. Awesome, so hopefully you got those same solutions there, or at least one of them. All right, we got 2 more examples to do. All right, and then it'll be time for you to practice. All right, so today's notes are definitely a lot shorter than yesterday's. Yesterday I just had to do a lot of explaining with this. All right, so hopefully this is all making sense. And then on Friday, why don't we try to get a Google Meet together here so I can kind of do some in-person talking and reviewing on Friday. All right, and I'll send out some information for that later today as well. All right, so example 5, it's x minus 5 squared plus 7 is equal to 81. All right, so my parentheses square value, my x squared value is kind of almost by itself, right? Except this plus 7 is with it. All right, so before I take the square root, I gotta get rid of that plus 7 because I need to isolate that whole x minus 5 squared term. All right, so here I'm gonna have to subtract 7 first from both sides. And then we get x minus 5 squared is equal to 81. All right, now I'm ready to take the square root of both sides, right? I take the square root of my left, I take the square root of my right. And when I do that, I get just x minus 5 now is equal to plus or minus 9, right? The square root of 81 is 9. All right, so now I'm ready to write my two equations and to finish solving this problem. All right, so again, my first equation is x minus 5 is equal to positive 9, and x minus 5 is equal to a negative 9. And now I'm going to solve both of these the same exact way, right? You add 5 to both sides. So here we get x is equal to 9 plus 5, which is 14. All right, and again, we're going to add 5 to both sides on this equation. But this equation, it's negative 9 plus 5, which gives us a negative 4. All right, so here my two solutions are 14 and negative 4. All right, again, pause the video for number 6. I want you guys to try to work this out through all the way through and come up with your two solutions. All right, so let's see what we did here for number 6, right? So 5 and 6 are very similar, right? We have x plus 7 squared minus 4 is equal to 60. All right, so first thing you got to do is get rid of this minus 4, right? Because I have to isolate this x plus 7 squared term. All right, so I'm going to use inverse operations to isolate this x plus 7 squared. Right, and I do that by adding 4 to both sides, and 60 plus 4 gives me 64. All right, so now I'm ready to take the square root of both sides because this square term is isolated. All right, so I square root both sides, and I get x plus 7 is equal to plus or minus 8, right? The square root of 64 is 8. All right, so now I'm ready to make my two equations, right? So we get x plus 7 is equal to positive 8, and we get x plus 7 is equal to negative 8. All right, and now to solve, right, I subtract 7, I subtract 7. So you get x is equal to 8 minus 7 is 1. All right, and then this second equation, I'm going to do the same thing. I'm going to subtract 7 to both sides. But this time, we have negative 8 minus 7 is going to be negative 15. All right, so again, hopefully you got those same answers. All right, if not, that's okay, because you're going to do some more practice after this. All right, and the last thing I want to show you here is just kind of a worked out example with all the different steps here. All right, so you can see in this example, right, there was a 6 out in front, so we divided both sides by 6 first. All right, that's isolating the square term. All right, and now we take the square root of each side, right, and don't forget that plus and minus. All right, because again, that square root gets rid of that square. All right, and now, right, we're going to write out our two equations, all right, one with a positive and one with a negative. All right, and then you just solve both equations. All right, so hopefully this made sense today. Again, if you have any questions, please reach out and email me, and go ahead and try the practice homework. And we'll meet on Friday to talk more about this stuff, okay?